What's up, folks? Glazer here. I'm going to talk to you about the lab for Thursday of week 3, which is entitled Waves on a String Lab. Again, these are some of my most favorite labs that we do during the year, but we did find pretty good simulations for you online. So I think it's going to be, I think you'll be able to see a lot of the same things. Okay, so I'm going to present and just jump into your lab here and show you what you need to know. We're going to go here, here. Okay, so this is the PhET lab right here. This is the setup. I'm going to show you a couple things that you need to check out. So for your first questions 1 and 2 of your lab, you have to click up here in the upper right-hand corner right here where it says no end. So you're on no end if it goes out the window. Loose end is like if it's attached, like, I mean, really the only example of this is a ring on some kind of pole or something like this. So it goes up and down, but it doesn't move horizontally. It moves vertically, but not horizontally, right? And then fixed end is if that end of the string was actually clamped down somewhere. So we're going to go to no end, all right? And then it says grab the wrench. You just click on this and you move up and down like that, and you're going to essentially generate a wave. Okay, answer those questions there. Okay, then you're on questions 3 and 4, the second little chunk here. Now you're going to go to fixed end. Okay, so now you have both ends of this thing fixed on. You've got damping and tension down here. We're not going to change the tension right now. We're going to go to damping. Remember, that's another way of saying friction. So if we put damping on 0, it's none. So this means if you generate a pulse, that will just go for an infinite amount of time if there's no friction, right? So it's perfect physics world here, okay? Let's see, what else are we gonna do? We're gonna go to up here in the upper left, you've got manual, which is what you just did because you grabbed it. You've got oscillate, which we'll do later. We're gonna go to pulse right now. And this has a little, this is like if you had a little machine that was pushing up and down, sending a pulse. So I'll show you this, okay? And then if you look on the bottom left here, you can change your amplitude and you can change the pulse width. So we're going to have you put, I guess you could slide it. We're going to have you put the amplitude all the way up to 1.25. And we're going to change the pulse width to 0.2 seconds. And I'll show you what that looks like. Okay. Then you hit the green button and boom, there's your pulse. Okay. Now the pulse is just going to keep going for infinite time because there's no damping, there's no friction. The amplitude is the height of that, right? Remember, amplitude is up and down, okay? The pulse width is actually how wide it is on the in seconds on the string. Okay, so that's that. We're going to ask you some questions about how that thing flips upside down and then travels back. And then once you're playing this, if you go no end, shoom, that thing just goes out the window and it's gone. Okay. Then we're on questions 5, 6, 7. What do we do here? This is, oh yeah, right. So I forgot, sorry. So 5, 6, 7, we go to loose end and you do the same thing. You start a pulse. You see what's happened. You'll realize, oh, that behaves a little differently now when there's a loose end. So now it's essentially on the generator on the left, it's a fixed end. On the right-hand side of your screen, it's a loose end. Okay, so what happens when you have one end fixed and one end loose? Okay, that is 5, 6, 7. When you want to get this thing done, you put no end. It goes out the window. All right, and now we're going to go to oscillate. Okay. Oscillate is up in the top left. Whoa, look at that. And we can check, that's our frequency of 1.5. You're going to pause it. And then it says click on rulers. Your ruler is down here in the bottom right of the screen. Rulers is right here. These are in centimeters. You should be able to get a pretty good estimate for your wavelength. That's what we're looking at you to do. Okay. And then we change the frequency. Then you're going to turn your frequency up to 3.0. We're going to look at what happens. Oh, look, the wavelength changes also. Okay. And then this takes us to 12, 13, 14. Okay. You should be at a frequency of 3.0 hertz, right? Abbreviation for Hertz is HZ. A lot of you kind of made up your own abbreviations last week, which was good, but the official abbreviation is capital H, lowercase z, okay? You can hit the slow motion, which is right in the middle of your screen right here. And if you hit the timer button down here, you will get a timer, right? And then you can, wow, then you can do this and you got all the stuff going at once, okay? So your wave is moving, you're timing it, you can measure it, all that stuff, okay? And we ask you to go back to the formulas we looked at from the very beginning of physics, really. Our velocity equals distance over time, okay? That's questions 12, 13, 14. And then finally, questions 15 and 16, we're asking you to change the speed back to normal, and then you're going to change the frequency on your own, which is this slider right here, okay? And kind of look at what happens when you do that to your wave. All right. It's a cool simulation. Again, I wish we could do this in real life with slinkies and strings and elastic and stuff like that. But unfortunately, we cannot right now. That would not be prudent. Okay, I'm going to say stop presenting. That's it. Hope you have a good one. If you have any questions, I'll be in office hours on Friday, right? And come on by and ask questions about this lab, and I'll see you later. Bye.